Hello viewers, welcome to Eugene TV. Please let us take a look at this question. This question was one of the questions that confused a lot of candidates in the just concluded WAEC chemistry objective test some days ago. So let us read this question. Alright, so the question says, the mass of sodium hydroxide that is required to prepare 250 cl cube of 2.0 mol per dl cube sodium hydroxide is, what is the mass? 16, 5, 50, 20, and 40 grams. Please, if you know the answer to this question, help me put the answers in the comment section. Put the answers in the comment section. Alright, okay. Is this question hard? The answer is no. This is a very simple question. The only thing here is that the question is tricky. Mind you, I say the question is not hard, but very tricky. Alright, so there are corners that must be cut before we answer this question very fast. Let's go. Okay, I am going to answer this question in two ways. Okay, so we say solution. We say solution. We are going to establish some things here. We are going to establish some things here. Now, we are going to use the relationship that says mole is equal to number of, mole is equal to concentration times volume in dNq. Alright, so let us see. We are going to use this formula that mole, which is represented as N, is equal to concentration in mole per dNq times volume in dNq. That is the first thing we are going to do. That is the first thing. But mind you, in the question, we were given the molar mass of this alkali to be equal to 40 grams per mole. So there will be no need of us calculating this. So let it be put there. The molar mass will give you. So let us find the number of mole from this number of mole of this alkali in this solution and this concentration. So number of mole here we say is gotten by multiplying concentration in mole per dNq by volume in dNq. So the concentration of this alkali is 2 mole, 2.0 mole per dNq. That is the concentration. Then the volume is 250. If the volume must be in dNq, we are going to divide this volume in dNq by 1000. By 1000. So when we have 250 and then we divide it by 1000, the answer is going to be 0.25. So the volume in dNq now is 0.25. 0.25. Okay, so we multiply it. When we have 2 times 0.25, the answer is going to give us 0.5 mole. 0.5 mole. This is the number of mole of this alkali in this volume. Alright, so when we have done that, we can now go and apply our formula that says mole is equal to, remember the first one we say mole is equal to concentration in mole per dNq times volume. Now we are going to use another one. Mole is equal to mass, let's say mass, all over molar mass. Sorry, that is, I made a mistake. We are going to apply this formula that says concentration in mole per dNq. Concentration in mole per dNq is equal to mass all over molar mass divided by volume. And of course, that volume is in dNq. Volume is in dNq. Let me say that again. Concentration or molar concentration is equal to mass. Remember, mass all over molar mass gives you mole. So we can as well say N all over volume in dNq. Alright. So because we are looking for mass, that is why we have to bring this. Remember originally, let me put it again, that mole is equal to mass all over molar mass. But in this case, we already have our mole. We want to find mass from there. That is why we are bringing this there. Alright. So we are going to say mole per dNq, concentration in mole per dNq is equal to mass all over molar mass divided by volume in dNq. Alright, so our mole concentration was given to be 2 mole per dNq. Let me put it there. 2.0 mole per dNq is equal to our mass. We were not given. They are asking us to find the mass, so it is there. Alright, the molar mass of that alkali was given to be 40 grams per mole, and then we divide everything by volume in dNq. Remember, if we change let me put it here again. If we change volume in CNQ, 250 CNQ, when changed to dNq, we divide it by 1000. We have already established it before that is going to give us 0.25 dNq. So, having that, okay, so our volume here is going to be 0.25 0.25. Let me take that again. This is mass all over molar mass divided by volume in dnq. Alright, let us evaluate. This is the same thing as saying mass all over molar mass, and make this one a fraction. Divide times 1. So we are going to have the same thing, mass, which we don't know, all over molar mass is equal to 2.0 times. So we are going to have 2.0 times 0.25 dnq. Alright? We'll come down again. Mass all over molar mass, which is 40, is equal to 2 point this times 0.25 is going to give us the same thing, 0.5. Alright, we are going, let me go this way. Let me divide our board this way. So, what is now mass? Our mass is going to be 40 times this, because we are cross multiplying. The same thing as making this one a fraction and then we cross multiply. Mass times 1 is the same thing as mass, then equal to 40 times this. So 40 times 0.5. This is the same thing as saying 40 times half, and of course half of 40 is going to give us 20 grams. Half of 40 is going to give us 20. Can you see that from our equation, from our solving here, our correct option is option letter D. Option letter D. I want to show you in another way how we can solve this problem. I want to show you another way we can solve this problem. Now, remember, the mass of 1 mole of sodium hydroxide was given to be 40 grams per mole, or let's just say 40. This is the mass of 1 mole of this. Now, for you to say, or for the equation to say 2 mole per dn cube of sodium hydroxide, it simply means that, alright, it simply means that 2 moles of this, 2 moles of the alkali was dissolved in 1000 cn cube. Remember, 1000 cn cube is the same thing as 1 dn cube. Alright, so 2 moles of this in 1000 cn cube is the same thing as saying 2 times 40. Why do I say so? 40 is the mass of 1 mole of sodium hydroxide. So if it is 2 mole, that means it's going to be 80. Let's say 80. 80 grams of this is dissolved in 1000 cn cube. This is the meaning of 2 mole per dn cube of sodium hydroxide. It means, remember, the mass of 1 mole of sodium hydroxide is 40. So the mass of 2 moles of sodium hydroxide is going to give us 480. And if they say 2 moles per dn, it means 80 grams of that alkali is dissolved in 1000 cn cube. Now, what is going to be the mass that will be in 250 cn cube? What is going to be the mass? We don't know. We'll call it S. I will make S subject of formula. S is going to be 80 times 250 all over 1000. I bet you by the time you press this, 80 times 250 is going to give us 20,000. And 20,000 divided by 1000 is going to give us 20 grams. Can you see? So in any whichever way, it boils down to the fact that you must understand the concept of mole. Alright, so even if you solve it using this way, you are going to arrive at 20 grams. If you solve it using this way, just a matter of you understanding the concept of mole. Please, if you find this video very interesting, give it a like, share, and comment. Thank you, and bye for now.